Okay, we're recording. It's official. Welcome, everybody. Thanks for your time tonight. Thank you, everyone, for joining on Zoom. My name is Joe Lloyd. I'm with Sparhawk Group. We're the firm that did the energy audit of these three buildings. A little bit about us, I guess. How are we qualified to do this? Who am I? Just a guy off the street. Our company was founded in 1990 doing energy efficiency and actually manufacturing in Maine. And as that started to disappear, we moved into the built environment. And so for the last, well, since 2000 about, we have been traveling all across the country, doing these reports. This is a level 2 report. There's levels 1, 2, and 3. Those are defined by our governing body on what that actually means. We agreed that a level 2 is the right analysis for this project. And I love when we can work in Maine because I live here and don't have to get on a plane and go somewhere. So that's a little bit about us. I was present personally for the site walks. We had 3 of our team members. We looked at 3 buildings. So if you do have questions, I'm not the sales guy. I'm just an engineer here. So take it easy on me, but I'll answer your questions as best as I can. So this is what we did. We did a level 2 energy audit. We did do a site visit. We reviewed utility data. We submitted it, a draft version, to the Conservation Commission, got some really good comments back, incorporated those into our final report dated here April 3rd. So I'm not going to read this whole thing to you. This is the team who did the work. I'm a professional engineer, certified energy auditor, so was Brittany. So we looked at these 3 buildings. The way that we break this down is at the beginning of the report, and I'll come back to this later. This is for our commercial clients, developers, people who only care about money. These are the only pages they look at. So this is what measures we've recommended, the priority which we've assigned, which is, it is not arbitrary, but it is sort of up to judgment. So you may see things with a higher or longer payback that have a high priority, or things with a lower payback that have a low priority. We can go over the reasons why we chose those things. And we broke this out by building. We considered the town office and the school to be one building because they are attached. They share some systems, although I understand, there's 2 different occupancies there. But if you look at our, our sheet, they're the same. Did the same here in the community center and also the fire station and annex. So I'll come back to these a little bit later. We also looked at some incentives. I suspect some of you may have questions about incentives. So what I'll say about that is since we've written this report, they have changed. And in the time between, if you decide to implement it now, and if you decide to implement a measure, they will probably change again. But they're all documented on efficiencymaine.com. The federal tax credits seem to have stabilized for now. To get those tax credits as a town, you'd have to partner with someone who can use the tax credits. We can talk about that a little bit later, especially when it goes to solar. This is the weather on the day of the site visit, October 28th, 2023. You know where the buildings are. I don't have to read that to you. What I did want to point out here is we weather normalize what we look at. So when we're looking at utility data and you're calculating energy savings, if you do it on a really hot year in the summertime or a cold year in the wintertime, your usage is going to be up, right? Cold years, we burn more oil. Hot years, we use more air conditioning. So what we did was we got the weather data from the Wiscasset Airport, which is the closest weather data that we could get. We feel like that's pretty accurate, pretty representative. And so this is how we normalize the weather. Next section of our report is all existing conditions. So this is what kind of takes the longest to figure out is what's there. We try to recommend things that are practical. So we don't want to recommend something that can't be built or can't be done. So that's our view. So we look at this as if when we do the energy audit, even though it's not engineering design, we look at it as if we were the engineer, could we do this here? Would the system work for you? So we did this. I will go through this relatively quickly, but we looked at everything that uses energy. This wasn't really a resiliency study, so we didn't look at that side of things. And I think some of you may have some questions about that, which is great. But this was really focused on energy use. So here's all your systems. This is how they're controlled. Heating, cooling, domestic hot water, looking at the town offices. We're looking here, these are some hallways, classrooms, unit heater spaces. We went all throughout the building. This is down in the basement. We did go in the basement, spent some time down there. We figured out how the boiler plant works and how it's controlled. There are many things that can be done with controls to help energy use. The good news is you've done them already. Doesn't let me put it in my report if you've done it already, but it's great for the town. So it's great that you guys are doing that. Continuing more pictures. Here's some air handling equipment for the gym in the school. We are looking at, here's the boiler plant. This is down in the basement of the school. This little guy, you can see my mouse. This little blue box on top of the boiler is the control. That's the brain. So we opened that up, looked at the LCD screen, clicked through all the menus and captured all the set points so we could understand how it was working. We also took a list of equipment and we are able to give you guys model numbers and quantities if they're visible. So sometimes with the circulator pumps, the model was rubbed off, so we couldn't see what it said. But for the equipment that we could see it, we wanted you to have this. So if you are doing maintenance planning or something in the future, you know, you can hand this report to a maintenance contractor and they can at least give them a start. We did the same thing for building envelope. I kind of skipped over this, but when we look at a building, we look at it as a whole system. So we're looking at the mechanical systems, heating, cooling, ventilation. We're looking at building envelope. Building envelope is really insulation, air sealing, stuff like that. We also look at lighting that uses energy. We look at the pump motors and we look at water and sewer. Now, in your case where you are on wells with septic systems, there's not cost savings from doing water and sewer. So we didn't go too far down that road, but we did look at it. We looked at all the windows. We went up in the attic. You've got blown in insulation. Your ducts are insulated. That's a good thing. Looking here in electrical works. And again, here's your list of equipment. Lighting, we did a lighting survey, so I'll skip to the end here because you don't want to look at a bunch of pictures of lights, there's a million of them. But here's the lighting that was in the building. We counted them all. I'm not going to say we couldn't have missed one or double counted somewhere. It's pretty hard to count lights, but this is our best effort at doing it. Water and sewer, as you can see, we looked at that, but I already mentioned why that wasn't a huge priority, just due to costs. So we did the same thing at the community center. This had a little more exciting findings around envelope. Here's how the building is heated. So for those of you that have been in the building, we've got this oil furnace that just blasts, it's not oil, but it just blasts out heat. And that's actually kind of good for the way that you use that building, where it's not occupied all the time. Having a big system that can heat up the building quickly when you use it is good. If that building were occupied, you know, regular office hours or 24/7 even, that wouldn't be the best system because it's not the most efficient. Building envelope here, so we found some areas that we got the vent in the floor that lets the heat go upstairs. We did find, let's see if I can find it. Yeah, here we go. This is what I want to show you because you can use this on your house too. So here's some shots. This is a gambrel building, I would call it, or maybe you would say this is the inside of that gambrel roof. Okay, what we're looking at, that's the stud there that holds it up. And here's the insulation, and this is sort of the passage into there. And you can see in the photo the cobwebs in there. So anytime, now that's nothing against cleanliness. I have cobwebs in my house, all right? So I'm not being judgmental. But what I want to share with you about cobwebs is if you see a cobweb, it means air is moving. Spiders are lazy and they build their webs in areas where air moves because that's where the flies go and then they eat them. So there you are. Anytime you see a cobweb, if you're walking around your basement, it means air is moving there. So that's something that we can choose to stop or not. but we did find it, and I just wanted to point that out. I thought that was cool. For my job, that's cool. So, you know, maybe you're not excited, but I am. That was pretty neat. Again, equipment surveys, lighting. We did a lighting survey at all the buildings. I'll scroll through that, and then here you go. So here's our lighting counts. This one was complicated. There's lots of different types of lighting in a community center. Water and sewer, we looked at that as well. Existing conditions, so here's the fire department building. And you'll notice these are all in the same order. They're all presented the same way. That's done on purpose. So as you're flying through the report, you can jump sections. You can look at it however you want, but everything will be ordered the same way. And the order that the buildings are presented at the beginning of the report for each little chart is also the same order that they are in the report. So we tried to be very consistent with that intentionally for ease of use. So yeah, here's your heating systems, hot water systems. Here's the control. I love this, that lock, don't touch it. I used to be a firefighter. I know firefighters mess with stuff. So yeah, I just got a kick out of that. Here's your equipment survey. Building envelope and ventilation. This is a little bit more advanced here. So you can see we've got some rigid foam in here. We still have some pink insulation. Pink and yellow insulation, they're both fiberglass. They both do the same thing. So you might have noticed in the other building it was yellow, in this building it's pink. It's still fiberglass. It still does the same thing. All right, so here's a good thing I'll point out. So we want attics to be vented. So where my mouse is here, this floor space, that's what we would consider the thermal barrier. It's really that's really the back side of the ceiling below. And that means that this space is allowed to be cold and it's allowed to be hot, and that's what you want. So these proper vents, they go down outside of the building and they direct the fresh air up the roof. If that is not done, insulation can get blown around and the system just doesn't work as well. So that was a good finding. Oh, good. Another one. Another life lesson. So we got our pink insulation. We pulled this up. So it wasn't sticking up like that. You know, we pulled it up so we could look at it. And you'll notice the bottom of the insulation is dirty. And again, no judgments here, okay? The insulation is dirty in my house. But insulation is an awesome air filter. So if you see dirty insulation or cobwebs, it means air movement. Anywhere you go. We're done with this. You guys won't need me anymore. You'll be doing your own energy audits. So there you go. We took a picture. We looked at all the appliances. We looked at water and sewer. We also looked at the annex building. Here's your equipment survey. Lighting. Again, I'll roll through this pretty quickly, but we took pictures of the lighting, did the lighting survey, and there's our photos of the annex. That was a pretty simple building. And here we've got our lighting survey. Let me zoom out a little bit so you can see better. Water and sewer. Here's some utility data. So we got actual utility data from the town and the school. And we put those into a bunch of different ways where we looked at, okay, what percentage are we using electricity versus fuel oil? What's the cost breakdown? So you can see here, like if you look at these two pie charts, it's almost 50-50 on what we're using. But electricity is more expensive per unit of energy. We'll hear a lot about electrification, and full disclosure, like I drive an electric car, I have heat pumps in my house, I'm a true believer. But electricity is a more expensive fuel than a lot of other fuels. Now, the reason that's okay is because it's also, if you're using a heat pump technology, or if you're using an electric car versus a gas car, it's way more efficient. So a gas engine might get you 20% of the energy that's in the gasoline you're going to use. An electric motor is going to be closer to 100%, you know, 98, 99% efficient. And with heat pumps, they tend to be on it. Well, the sales guy will tell you they're 3 to 4 times as efficient. The reality is the efficiency of a heat pump changes with the exterior temperature. So if you're in heating mode, the colder it is, the harder the heat pump has to work to pull heat out of the cold air. And you'll be down around 2x efficiency. So I hate to say 200% efficient because that's not possible, but it's a great way to think about it. So if we're putting in 1 unit of electricity, we're getting 2 units of heat out. And then when you're getting into your shoulder seasons for heating, so actually it's been kind of cold for August this last week or so, right? And I thought about turning on the heat in my house. I didn't, but I thought about it. On a day like that where it's 50 degrees, you're going to be above 300% efficient. So for every unit of electricity you put in, you get 3. So this is not to say that electricity is a bad fuel. No fuel is good or bad. I say fossil fuels are bad. But that's just how it is. And I just want to be clear about that. These are the rates you're actually paying, average utility costs. And then we developed usage profiles. I won't specifically go through these all because we didn't see any problems. So sometimes we will see a usage profile that tells us there's something wrong, like there's something in the building that is stuck on, or there's something in the building that is just not working. So we can tell the use just drops. We didn't see any of that here. And you'll notice the fuel oil line is really jagged. That's because it's a trucked fuel. So when you have a fuel that, like natural gas, that is delivered to your building, you pay a monthly bill and you know exactly how much you use every month. You get a really pretty graph. When you're buying fuel from a truck, some months you're going to get a bigger delivery, some months you're going to get a smaller delivery, and it does put a little bit of noise in the data, but nothing concerning here. But that is why it's jagged like that. I just wanted you to know. So very, very similar here. So this is the community center. You can see it's mostly fuel oil, very little electricity use. But when we look at the cost, you know, it does bump up a bit. Same reason as before. Very normal curve here. Yep. Someone had a question? No? Okay. Same with fuel oil. You can see that it's a very jagged line. And we don't have any water data, so we normally would put in a water usage profile here, so we said, well, we don't have that. Fire department, mostly fuel oil, and we mentioned, yeah, we beat that horse, so the electricity costs more. And then we've got a pretty steady electric use. You can see a nice little peak here in the summertime. That's what you expect to see with electricity in a non-electrically heated building. Something happened here, you know, back in December, maybe we had some meetings there. We used a little bit more electricity, but that's nothing to worry about. And yeah, the fuel oil use, very jagged. Then we can go into, I will sort of roll back up to the top after I get to the bottom. But these are the details of all the energy and water efficiency measures that we recommended. And we talk about the baseline condition and what we would think should be installed. So that's listed for each measure for each building. And this is many, many pages.
Just to interject, Joe, if anybody wants to read those pages, we have a paper copy at the town office, or I can email them.
Great. Yeah, please do. I mean, the only reason I'm skipping through these is because I'm going to go back to those charts and then we can talk about each one if anybody has questions. So I'm familiar with this, what we recommended, why we recommended it. We did also, so the good news and the bad news. So the good news is that your buildings don't use all that much energy. So the town, the people who run the community center and the fire department, the town office, and the school also have been really aggressive in making the best of what they have, the best of what the systems are. And so typically when we do our analysis, I'll come back to this a little bit later, but we look at things like simple payback. So simple payback is how many years, if I buy this efficiency upgrade, how many years is it of use before I get my money back, right? And so many of our paybacks are pretty long on the things we recommended. And there were also many things that we didn't recommend because the usage is so low and we didn't think that the savings would support it. But several things we looked at, you know, we looked at doing rigid foam exterior insulation. That's a great upgrade. We are working on a school project now in Topsom, Mount Arrett Middle School, where they're doing a total envelope retrofit. That can work really well. Air source heat pumps. So we did recommend heat pumps, but we recommended the mini split type, which is a more residential type of technology. There's something called variable refrigerant flow, where if you have a building, you will put many different indoor units in it. And you put in these things called branch boxes. And when the magic is in the branch box, and what those things do is they allow, if one room is hot and someone wants cooling and the other room is cold, imagine the sun's on one side of the building, not on the other side of the building. That allows the refrigerant, which is how heat pumps work, they use a refrigerant, allows it to swap between rooms. And so you gain this insane level of efficiency, but those systems are incredibly expensive. And because the usage was low, we just didn't think it made sense. Looking at, again, spray foam insulation, same reason as cost. Water conservation, we didn't recommend because there is no cost associated with it. Blower door targeted air sealing can be great. Weatherization companies that come in, they'll set up a blower door. So what a blower door is kind of what it sounds like. So we've got a door here to my left. It's actually kind of a tall door. I don't know if our blower door would fit in this door, but if you're using a regular size person door, it's a frame with like a plastic cover. Almost looks like a balloon. It's a vinyl material, but almost looks like a balloon. You put it in the door. There's a fan that goes through that unit, and you suck air out of the building. You can also go in. I don't like to blow air into the building because if there's anything that's put together with tape or sealant, you risk blowing it apart and making the building worse than it is. If you blow air out of the building, you're sucking everything together and it wants to stay together. So we like to do it that way. There are some standards around that, and then we could say, hey, whatever your starting number is, knock the air leakage down 30%. Like go around and seal the building until you've knocked it down 30%, and then they'll stop. Again, didn't recommend that because of cost. These were all really because of cost. Electric motor efficiency upgrades, you have a lot of premium motors already. And there was a conversation when we were in the school, there's a beautiful mural in the school library that they're concerned about preservation of that. That is a great thing to do. It's not going to be funded by energy use. In fact, it will increase the energy use of the building if we put in proper dehumidification and do all that stuff. So I didn't put it in here in the energy audit, didn't think it was appropriate, but we did want to flag it as a thing, as an idea. So it's out there. Domestic hot water system, the reason we didn't recommend replacing it is because none of these buildings really use that much hot water. They're not residential buildings, and again, with cost. Community center, it's going to be very similar. So for each building, we did some measures that we evaluated, that we looked at, that either we thought about while we were there or we did the math. It could be either one, and decided not to do it. Again, it's going to be very similar for each one. And here is our math. So we show our work. If you're curious on how we calculate this, I don't give the formulas, but you can figure it out if you Google it, or if you take an energy auditor class or buy the book, they're all in there. The cells that are orange are inputs, the cells that are gray are outputs. And so this is how we calculated all the measures, the savings. You can see all of our assumptions that we made. There aren't very many assumptions made because we had a lot of data, right? We went around, we counted all the lights, we looked at the efficiencies of the equipment, but it's all in here if you're ever curious and want to look. Our final, appendix here, this is the utility data that was provided to us that we used for this, and that's the end. So now what I'd like to do is go back to these charts, and we can go by each building. We recommended some lighting, heat pumps, a boiler replacement, indoor temperature reset we can talk about if you're interested, air sealing of exterior doors. We noticed the weather stripping had gone bad, insulating and air sealing the attic, and then again, more lighting. At the community center, Unfortunately, we recommended very few things. The usage at the community center is very low because it's used pretty much 1 day a week. And well, that's all there is to it, I guess. I don't have much to say about that. Fire station annex, there is more activity at the fire station. So we had a few things here. So looking at lighting, putting in air source heat pumps, furnace replacement. Those are somewhat mutually exclusive. I would maybe do one or the other, or you could keep your furnace and use the air source heat pumps to supplement. That would also be okay. And a refrigerator replacement. The refrigerator in there was all, I'm sure you guys would like a new fridge. That is the 27-minute version of the 93-page report. So I really was hoping that we've got some people here in the room. We've also got a lot of people on Zoom. I was hoping to take questions and answer those questions. Would anyone like to be first? I'll take questions. What I'll do is I'll take questions from folks in the room. And if you're on Zoom, raise your hand and I can promote you to a presenter. But I'll probably catch up with you after the folks in the room, if that's okay.
Would it be possible to go to the fire station and perhaps the large vessel is readable and we'll look slow so we know.
Absolutely. So here's the fire station. Is that big enough? If I go any bigger, it's going to kind of go off the page. So the question was, can we look at the fire department measures in particular? And so we've recommended a refrigerator replacement, furnace replacement, air source heat pump, conversion, and then lighting replacements in the apparatus bay. We did find some incandescent lighting, which is pretty amazing. You can't buy that. Haven't been able to buy that for quite a while. So good job being efficient with your lights and not using them. They haven't burned out yet. And exterior lighting replacement.
What do you recommend the apparatus bay lighting replacement?
All right, let's check that one out.
Specifically your problem.
Yep, let's look at it. So let me just scroll down to that measure. It'll take me a minute. I'm gonna move my Zoom stuff is kind of in the way here. Just a sec. Community center, fire department, apparatus bays. So replace all apparatus bay lighting with either screw-in or permanent LED fixtures. Design Lights Consortium, which is DLC, and Energy Star are both organizations. Can't read it.
Can you pull that up?
You got it. Absolutely. I was just reading what it said. So.
Okay, well, the question I guess I've got specifically is in all the apparatus bays themselves. We replaced all that lighting a couple of years ago. It's all LEDs.
I don't think so. It looks like yeah, I believe you, but when we looked at it, it looked like fluorescent to us. If it is LED, then yeah, we didn't get up on a ladder.
The guy covers on it, make it look like an old school LED.
I gotcha. Yeah. Well, don't do that measure then. Thank you. Thank you. One thing we did note is that there are varying lighting levels in the apparatus bays, right? There's areas where it's easier to see and not as easy to see. So one thing, yeah. So that's one thing that can.
I mean, in the entire building, the apparatus bays and the upper rooms, all of those things have been replaced with LEDs. The annex is from day one, it's all LEDs.
Yeah, let's look at that. Because it's definitely not. I believe you on the apparatus bays because I didn't go up there and on a ladder and look at them. but let's look at the existing conditions. Because we got photos of non-LED lights. So these are the LEDs you're talking about here?
Yeah,
Okay. So right here in the attic, that's not an LED.
no, that's,
No, just in the base.
Right, but well, you said everywhere, so this is a fluorescent light.
I mean, the number of non-LED lights in the station is very small.
Okay, well, we should replace those. Here's a fluorescent light right here. Here's an example of one. This is non-LED, this is also non-LED.
No, sorry, that certain thing is an LED. Yeah. Not that one, the one on the left.
That one?
Yeah.
Okay. All right, fair enough. Thank you. Other questions about the fire department measures? Let me go back up to that.
I have a general request. Could
Please.
people who are in the room and speaking, please identify themselves? Because well, all we're seeing on the screen,
Is
those
the
of us who are
report.
Zooming, is the report. And we have no way of knowing who's speaking, and it's rather garbled. Your presentation is very clear, but especially because this is being recorded, I think it's important to identify the people who are speaking and to know what the conversation is about. This is Bronwyn Tudor speaking. I'm a select board member, and I want to thank you very much for this very interesting presentation of specifics in the report. So I don't want to impede the questioning, but it's very frustrating not to be able to hear the whole question and not to know who is making the inquiry.
Yes,
Thank you.
I will do my best to repeat the question. What was your name, sir?
Trevona.
Bob Trebona was the questioner. So thank you, Bronwyn.
Thanks, Bob. And Joe.
So we did find a few, but I guess you've replaced them all, and that goes along with what we were saying, which is most of these items have been maximized already. Now, are you able to see?
Here's the question on the screen right now.
That's what I was wondering, if anybody's raising their hand.
I have a question, but I
Okay, we have a question in the chat from David Fay. The question is, I may have misunderstood you, but if incentives are coming from federal IRA, municipalities don't have to partner with anyone to get tax credits. They're now eligible. Well, that is great. I did not know that because we're not accountants, and we actually haven't done that much IRA stuff yet. But that's great news. Thank you, David. Please, okay, so we have a question from Kathy Ravina.
Kathy Rubino from Bay Point, and I'm asking the question about the mini splits that you have suggested. Do you recommend, would you in this report or as part of your report with us recommend specific placement, or would that be something that we entirely, or would that be something that we would do?
Right, so the question was, yes, I will repeat the question. So the question was, where we have recommended air source heat pumps or mini split units, would we also select where those should go? That is a little outside the scope of this report, but I think the best way to cite those is to walk through with a qualified contractor and with the people who are going to be using the building the most, and let them know where people are, and also they can figure it out from there. The only things I'll note with those, there are people are different. So if you, well, personal anecdote. So my wife sits underneath the heat pump at our house. She likes it blowing on her. I don't like it blowing on me, even if it's in heat mode. And we will, we'll look at that. All right, so we have a question.
I'll just move down here.
Thank you, David Fay. Were you surprised by the low energy use intensity? Yes, I was. Yes, I was. It's remarkably low. And we think that's due to, there's pretty aggressive boiler controls on there that they're using. And people seem to turn off lights when they're not in use and do all the energy conservation behaviors. Question from Aria, what's the average life of a heat pump? The average life of a heat pump can be, so you can get a warranty on a residential heat pump now for 10 years. I would imagine if the warranty is 10 years long, this would be on a Mitsubishi that's installed by a certified contractor. And I'm not familiar, I'm not shilling Mitsubishi. I don't own any stock in Mitsubishi. I don't get any money if we buy those, okay? But it's just the one that I'm most familiar with because I see them a lot. If you put one in with a certified contractor, they'll give you a 10-year warranty. Sometimes it can be as long as 12 years. I don't know that since we have started this aggressive heat pump installation program in Maine, it's been about 7 or 8 years. I don't know that we have that data to say, do they last for 20 years? Do they last for 30 years? I hope that they last for a very long time. Oh, is that you?
Thank you, Joe.
Yes, you're welcome. And let's see, I'll pull up the chat as well. Feel free to either raise your hand or type questions into the chat. That's working really well. I don't see anybody with their hand raised.
Joe, this is Kathy Rubino again. I just want to say that since the town received this report, the people from each of the municipal buildings that you studied have come together as one group to kind of think about what would be the next steps, which I think is a very practical way of ensuring that we are not duplicating or getting economy to scale in what we're looking to do. That's more information from people.
All right, I'll unmute myself here. So I see I'm still on Zoom. This is Joe Lloyd. We had a little technical difficulty here in the room. We had a statement from Kathy Ravino about how since we've received the report, we being the town, the people with the 3 different buildings have worked together to try to make sure they're not duplicating stuff or that items can be, done together to get best cost. So that was a statement from Kathy. Hopefully I summarized that relatively okay.
Thank many community members helped when you did their tour around in the fall and it helped gather information, particularly the town office. We have a few years ago we had a municipal working group that actually did some groundwork and just showed the importance of doing this kind of stuff. So
Lovely.
I've been very fortunate that I have a lot of people in the city are very interested and spend a lot of time.
So yeah, another statement here from in the room from Kathy, thanking the people who were involved. I think I should thank them as well. We had a great crew walk around with us when we went to these 3 buildings. We asked for a lot of data. It was work that people had to go do and get, and we're thankful for that as well. And also the people that came before. So showing that there was a need for this was very important.
And the only thing I'd add to that, Joe, Tyler Washburn, town administrator, is that I think it's particularly impressive that tonight we have representatives from all of the stakeholders, fire departments, community center, and town that clearly show, dedication to maximizing the potential of people.
Great. So Tyler, statement from within the room. Tyler Washburn, he stated that it was great that we have participation both on Zoom and in the room from people from all 3 buildings. Mike Farina got a great question here. do you recommend heat pumps that have auxiliary heating elements for times of extended cold periods? That is a great question and worth debating. Personally, no. If you look at the design data, so looks like we're coming back here on Zoom. But anyway, if you look at the, all right, just one second. I gotta mute this. Okay, now we no longer have an echo. So the question about, do we recommend auxiliary heating for heat pumps? That's kind of a two-parter. So I would say, firstly, if you, in a case like the fire station, if you intended to leave the existing furnace there and use the heat pumps as a supplement to that, you definitely wouldn't need it. If you are going to do an all-electric building, get rid of the fossil fuels, there's two pieces to that. So one is if we do insulation and air sealing, which wouldn't be a good payback, but it would help the building use less energy. We really don't need heat pumps that have extra heating capacity. So the reason for Mike's question, let me give a little bit of context. So he's got a really good understanding here and understands that the heat pumps work harder the colder it gets outside. Well, in addition to that, there is a level of coldness where they don't work anymore. That tends to be negative 23 degrees Fahrenheit, which is very cold. I'm not sure that it's ever gotten that cold here in Georgetown. If you look at design data, and unfortunately I don't have design data for Georgetown, I've designed data for Portland, Caribou, Bangor, the big cities, or at least the spread out cities. Portland's mechanical engineering design data is 7 degrees F. So that means that 0.7% of the year, so 7%, it will be colder than 7 degrees Fahrenheit. With that level being warm, much warmer than the heat pump's limit, we think that they'll stand on their own. And give you a little bit of context too, in new construction, we are seeing buildings built with no backup heat that are heat pump only. Some of these are schools. Some of these are fire stations. Augusta Fire Station just did that. They have a VRF system, which is that fancy one I was telling you about. They've done that. They don't have backup, and they don't have electric heat. I'm seeing passive house residential buildings, 24/7 occupied residential buildings with no backup heat. And the policy, and people have made some great points here about IRA. I learned something tonight from David, but policy, at least as far as Fish and Humane, is changing where if we are putting in backup heat at the same time, they either reduce or eliminate your incentive completely because they want it to be fully funding the heat pumps. Kind of a long answer to a short question, but hopefully I got it for you, Mike. All right, let me look at our participants. Anyone else would like to send me a chat or raise your hand, please do. We have some great questions so far. I'm loving these questions. All right, we have a question from within the room. I'll repeat it.
I'm Mary McDonald. I'm wondering about disposal of your heat pumps.
That's a question I've never been asked before. All right, so the question is disposal.
It's 10 years down the road, and Terry Taylor's heat pump just died.
Right, so do you say your name was Mary McConnell or O'Donnell? Sorry, McConnell. Mary McDonald. The question was disposal of heat pumps. What do we do with them when they break? You have just scratched the surface of a much bigger question.
I know.
So,
and that I personally believe it's going to be problematic. The state of Maine and everybody else.
Right, so Mary thinks it may be a problem. I tend to agree, but it's even bigger than you think. The refrigerant that's currently used for mini split heat pumps or these types that we've been talking about and recommending is going to be phased out in 2025 or 2026, depending on who you ask. The EPA has decided we're not doing that refrigerant anymore. Now, that doesn't mean we're not going to be able to buy heat pumps. This has been on the docket for 10 years. All the manufacturers know about it. They are building heat pumps now for delivery for projects in 2026 that use different refrigerants. But what that does mean, and this is to your point, if you have an R410A system, which is what they use now for this size of a system, you will not be able to replace it in like kind. So it will have to be the refrigerant. It's not like what could I compare it to? It's not like changing the water in your heating system, I guess, right? It's not, one cannot be traded for another. So the compressor, which is what makes the heat pump work, needs to be different. The piping sizing needs to be different. The sizing of the indoor units and the outdoor units and all their fins where they blow off heat and they heat your space all need to be different. So I don't have a great answer for that. That's something that the industry is working towards. I've been, quarterly, I get emails from Trane. Trane has a joint venture with Mitsubishi. We are going around trying to solve this problem, but it is a problem that's out there. The other thing, and this is maybe the flip side of your coin, if your heat pump lasts for 30 or 40 years, which I certainly hope that it will, the cost of refrigerant is going to increase. So right now, our 410A, you can buy it at the plumbing store. They won't sell it to you without a license, but I mean, a qualified person can buy it. And if you have ever tried to purchase R22, which is also known as Freon, it's about $700 a pound. Now we're talking about ounces of refrigerant in these systems, ounces and pounds. So it's not going to be a $100,000 bill to get new refrigerant. But as that refrigerant gets used up,
Apparently, I was communicating with my.
you have to buy more. There will eventually be a leak in the system somewhere. Refrigerant will escape.
Someone is not muted.
And that's another thing that can happen. All right, we've got a question here from Cheryl. Given concerns about climate change, storms, and resilience, how does your report inform Georgetown's response to climate change and the town's carbon footprint? So our report does not, it was not a resilience study. We do those, but this is not specifically focused on that. So I guess the answer is that it doesn't inform it. What I can say though, is that any switch to an electrical fuel, electricity is not a fuel, but I consider it as a fuel for heating source. Any switch to electric fuel is going to help with lowering carbon footprint, especially if you buy clean power. And anything you can do to minimize your energy use also hedges you against increase of utility costs, and it makes it more resilient, right? So if we are spending less on energy, then we can run the stuff we have longer before we have to replace it. But no, this was not a resilience report. Great question. Let's see who else we have. Oh, we already lost somebody. Must be boring them. That refrigerant discussion that I just spent 2 minutes on is like, I've gone to 2-hour-long presentations about that. It's a huge deal.
Yeah, well, I think my biggest concern was that I understand that a lot of these solar panels that people are, putting up now are having real trouble with.
Right, so Mary, yeah,
So I was
so,
wondering about all this, I'm all for efficiency, don't get me wrong, but at the same time, our kids are gonna have to dispose of this stuff somewhere,
yes.
and I'm a little worried about that part.
Yeah, so Mary's question, hearing about PV, solar photovoltaic, and trying to get rid of those systems, that's a whole nother conversation. You're absolutely right about it, that it is difficult. I like the way you're thinking. I mean, I try to think of, people say I'm gonna throw it away, right? There's no away. Like, where is away? It's a landfill somewhere. It's in somebody's yard. It's next to somebody's house. There is no away. So I think thinking about what we're gonna do with stuff is really smart. As far as heat pumps go, there's a lot of copper in them that can all be recycled. The cases are generally made out of steel or aluminum, and that can be recycled easily. The things in the heat pumps that you're not going to be able to recycle would be like the printed circuit boards, the electronic components, but those even will be sent out and someone will take the metal out of those. So yeah, I think with the heat pumps don't usually use like the rare earth stuff like you'll see in solar panels or electric cars. That can be really hard to dispose of or recycle. And with a heat pump, if it is at end of life, and this is true for I keep saying heat pump, but this is true for your air conditioning systems, for anything that uses refrigerant. It is illegal to discharge refrigerant into the atmosphere, period. And if someone does it on purpose, they can lose their refrigeration technician license, which they don't want to do because that's how they feed their family. So what we do when we take these systems out of service is we reclaim all that refrigerant. So if you have a bunch of R410A systems, let's say we're like, hey, we're going to do this. We're going to get an RFP out. We're going to get these in 2025 with this refrigerant that we know and love before we don't know what's coming down the pipe. We're going to do it right away. That thing lasts for 30 years. It's time to replace it with the new refrigerant. You're going to be able to recycle all the components. There's scrap value of that. I mean, the metals are easily recyclable. We have a process for that. And then the refrigerant will be reclaimed and you can sell it. Or you can have your, you wouldn't sell it yourself, but you could say, hey, this refrigerant in this system has value. You can include that as part of the RFP and say, whatever you're selling this back to, we want, a cut of that, or we want that reduced from the price. So I think you have a great question. I do think heat pumps can be recycled, but really no one has ever asked me that before. And so I'm just talking out loud here because, yeah, great question. Please go ahead.
John Collins. But as far as the refrigerator, you're talking about the new stuff doesn't require different refrigerator. If we have something that's old, it's that the one that's being used presently, are they going to phase out production of that stuff? So if you have a leak in 2027, are you going to have to change out the whole system because you can't get that older type of
right. Okay, so question from John Collins on the select board. The question was, if we put in a system today with a certain refrigerant that is then outlawed and there's a leak in a few years, are we going to be able to replace that refrigerant? Is it still going to be produced? So great question. The answer is no. So they're not going, well, the answer is yes, you can fix it. No, they won't produce it. So because all of these systems have to be reclaimed, that refrigerant that has been produced is out there, right? We're using it now. It's out there. It's in all these buildings. It's in my house. I mean, it's in a lot of places. And so we have that now. That quantity of refrigerant will be fixed. They'll stop making it. There won't be any more. And that's why the price will go up. So as they start taking systems out of service and reclaiming that 410A, you can buy it if you have a leak. So it's not just to say, hey, tough luck, you have to buy a whole brand new thing. The cost of refrigerant over time will increase. And R22 now is very expensive, but it wasn't for a while. It took time for that change to happen in the market.
like the mid-80s, early 90s, they changed the refrigerant all the car systems. So 12 or something, or like 34 or something like that. I just remember that changeover happening. So I was just curious.
Yeah, so John was mentioning the refrigerant changeover in cars, and it's a similar thing. So, right, the systems are independent, don't work together. Okay, let's see. Question from Susanna. I look forward to reading the report in detail. Would you say that there are available grants or incentives that will make the highest and medium priority recommendations feasible? I think so. I mean, we only tried to recommend things that we thought were feasible. So you can see there's a big long list of stuff that we didn't recommend. The IRA was mentioned, so IRA funding. And David, please correct me if I'm wrong here, but my understanding is that money goes to the county and then it's distributed out. I don't know exactly how all that is coming out. Where I'm seeing the IRA funding, that's the Inflation Reduction Act. Where I'm seeing that in the market is coming out as new buildings are being built by the counties, is what I'm seeing.
Other question?
Yep. There are also state incentives, very heavily favored towards heat pumps, by efficiency made. I just want to hit both of those. Another question from Bronwyn. In the past, the heating system for the town office has been tied into the school since they're part of the same building. Given your analysis, is there any reason to think if we were to separate the office heating cooling by heat pumps, it would have a negative impact on heating for the school? I do not think there would be a negative impact for the school. The school has enough of a load on the heating system that removing the town office wouldn't hurt it, wouldn't cause it to short cycle. Short cycling would be like if you started your car and floored it and then got to where you're going and left your foot on the floor the whole time and then got to where you're going, shut the car off and then started again and did the same thing. So that's bad for equipment. Hopefully none of us would do that to our cars. We don't do it to our boilers either. I think that's what Brown's getting at, and that would not happen here because the school is the big piece. Now, if you shut down the school, if you said, we're taking the school off the heating plant, we're gonna leave the town office on the heating plant, that could cause problems because that's a smaller area, right? But no, great question. I don't think there would be any negative impact.
I'm a Washburn town administrator, so I know we can't really talk generators, but in terms of a benefit for a heat pump, in the event that the town were to switch over to heat pumps versus being on the boiler, we did get a generator, and that was our primary heat point, over the building to get that heat. Is that potentially something that overloading generator more than the boiler does, or is that something that's kind of like this point in tech to work itself out as it goes down, the wind blows, we lose power?
Okay, so we got a question from Tyler Washburn about a few things, but mostly about if we did heat pumps in the town office, would we be able to supply that with a generator so that we could open the town office when their power was out, right? Okay, so that's my summary of the question. And the answer is you definitely can do that. I don't know that it would necessarily be a super sure winner energy project. It might be a great resilience project to do. The key thing is your existing generators, I don't think would handle it. So you would have to upgrade. And it's not that, I think Tyler used the word overload. So he said, you know, would heat pumps overload the generator more than the boiler? Boilers use a lot less electricity than heat pumps do. And the reason is they use electricity for their fan and the blower motor in the boiler. They use electricity for the pumps that pushes the water all the way around the building, but that's about it. Whereas a heat pump, you are using that to heat. So the trick is just to, if you kind of integrate the project or maybe do them at the same time, make sure your generator is big enough to run them. I would also suggest if you're going to run heat pumps off a generator and that's your plan, ask the generator manufacturer about power conditioning. The reason is that when generators make power, it's not as clean as power that comes from the utility. So what's clean power? What does that mean? It means that voltage is within a pretty tight range coming from the utility. And it also means if you ever look at alternating current, it makes this pretty sine wave. If you go back to 8th grade math, it makes a real pretty sine wave. Generators tend to switch a little more harshly. It looks a little more like a sawtooth pattern than a nice ocean wave pattern. And that can be hard on equipment. Now they've gotten better, generators have gotten better, but I would just say, think about power conditioning. And if you don't do power conditioning, the heat pump installers themselves can put a protective device going into the heat pump that will shut the heat pump down if the power quality is not good enough for it. Now, you lose heat if that happens, but it saves your heat pump from breaking. We had a project, we didn't design it, don't throw the books at me. It was a project we were asked to troubleshoot. It was a school in Sullivan, Maine, which is near Mount Desert Island. They also have issues with power quality there. And they had put in a brand new variable refrigerant flow system. It was a super awesome system. And their compressor, which is the expensive part of the heat pump, kept failing. And what we ended up doing there, the utility Versant, which is formerly known as Bangor Hydro, I sound like I'm not from Maine. They couldn't guarantee high quality power. So what we did instead was we put this protective device on every single heat pump. And unfortunately, they lose their ability to heat or cool when there's a power issue. But as soon as the power issue is resolved, it comes back on. I'm not talking about an outage. I'm just talking about voltage dropping or going out of range. So this is something we could talk about for quite a while. Great question. Thank you, Todd. Looking at our participant list for further questions. I've also been told, so that was a Daikin heat pump system that had that power quality issue. It wasn't their fault, right? It was coming from Versant Power. But I've been told that they are now shipping their units with those protective devices. Yeah, for the big commercial ones. For this size, I'm not sure that they are, but you know, Mitsubishi, Daikin, Samsung, LG, I've seen all four of those manufacturers perform really well. One of the other things that our company does is construction testing on behalf of the owner. So we will go into a building and test systems once they're working. Once they've been set up and they say, hey, it's ready to turn over to the owner. We say, okay, well, just wait a moment. We want to test it first. And we go in and test it and make sure it works. So I've seen all those four brands work very well. Samsung has some really attractive, well, all right, I'm not an architect. Their heat pumps, they're probably still ugly, but they have some better looking indoor units than some of the competitors do. Yeah. There we go. All right, I'm not seeing any hands raised here. Questions? Did you get any more? Do you have any more?
No, just thank you for coming down tonight to make sure the town of Georgetown can
Oh.
hear more about this awesome audit. Same breath, allow us to report it so even more folks can dive in and learn quite a bit about the things that can happen in our town.
Yeah, Tyler thanked us, and you are most welcome. We were really pleased to be a part of it. My family has had a summer home here since before I was born. I love the town of Georgetown. And when Tyler called, I was really happy that we could be a part of this. Thank you, everybody.